Welcome to Theory of Computation class. Today I am going to discuss the problem for conversion of epsilon NFA to NFA. So in last class I give the proof for conversion. For example, if you take epsilon NFA with 5 tuple representation, we should need to calculate the transition states for the NFA. So the calculation is step 1. First we should calculate epsilon closure values for all the given states in epsilon NFA. Then in a representation, that is we want to calculate extended transition function tilde dash. How can we calculate? Means the number of states into number of input symbols. That many times we want to calculate it. So how can we calculate? Means the formula is epsilon closure of tilde cap of q comma epsilon comma a. A means the input symbol in sigma. Okay, so this is the given problem. So if you take this diagram contains epsilon as an input field. For example, the sigma contains two alphabet symbols a comma b, which also consider epsilon. So the given diagram is stated as it is an epsilon NFA. They are asked to find out NFA. So the problem is conversion of epsilon NFA to NFA. So first we should understand it. Then you should write the given values from the diagram. So you write Q. So Q means Q0, Q1, Q2. And sigma is only write the alphabet symbols. Then you should calculate tilde dash of Q comma sigma. So how many number of states are there? 3 states are there. 2 input symbols are there. So you should calculate 6 transition function values. First you should write all this thing. Then step 1. What is step 1? Step 1 is epsilon closure calculation. So you should write epsilon closure values for all the given states. So totally 3 states are there. You write that state values. So whichever state we should need to calculate epsilon closure value, that state should also be included in a set. So epsilon closure of Q0 is Q0. Then from Q0, you just check whether any outflow is there. So there is no outflow with the epsilon value. So only Q0 is the answer. Epsilon closure of Q1 is Q1. From Q1, epsilon closure out path goes to Q2 state. So you write Q2. From Q2 there is no out path, so only Q2 is available. So this is step 1. And step 2, you should calculate the extended transition function. What is your starting state? Q0. And the input symbol is A. Then next you write Q0B. The same thing that should need to calculate values for Q1A, Q1B, Q2A, then Q2B. So you should calculate 6 values. This is the notation. So what is the formula for extended transition function? The formula is epsilon closure of tilde cap of this state is Q0, tilde dash of Q0 comma epsilon. The input symbol is A. So what is the value? This is nothing but epsilon closure of Q0. So you write the answer. This is epsilon closure of tilde of. This value is nothing but only one state. So Q0, the remaining symbol is A. Then you check the Q0 A with the given diagram. If Q0 with A symbol, it goes to Q1. So the answer is epsilon closure of Q1. So you just check what is the value of epsilon closure of Q1. It's nothing but Q1, Q2. So you write the answer. Okay. Then the second one, Q0B means you write the formula. Epsilon closure of tilde cap of. You want to calculate value for Q0 state. So here you should write epsilon and the input symbol should be B. Then epsilon closure of. The answer for this one is Q0. So you write it Q0 with B. You just check whether any Q0 B is there. No. So the answer for this one is pi. There is no state. So epsilon closure of null set is null set. So there is no answer for this one, or simply you put underscore or dash in the table. Then Q1A, the formula is epsilon closure of tilde cap of, I want to calculate for Q1 with epsilon and the input symbol is A. Epsilon closure of, the answer for epsilon closure of Q1 is Q1, Q2. So you write it here, Q1, Q2. So you should calculate Q1A value and also Q2A value here. Then what is Q1A? There is no value is with the Q1A. So the answer is pi. Q2A, there is no value is there. So this is also give pi value. Then Q1B, epsilon closure of tilde cap of Q1 epsilon comma B. Epsilon closure of tilde of this Q1 epsilon is Q1 and Q2. Just check Q1B, there is no Q1B, so the answer is pi. Q2B means it gives Q2 state. So epsilon closure of Q2, it's nothing but Q2 state. Then Q2A means epsilon closure of tilde cap of Q2 epsilon comma A. Epsilon closure of tilde of Q2 epsilon means epsilon closure of Q2, it's nothing but Q2. So Q2A, you should check the answer. There is no Q2A value, so this is pi. So there is no state for Q2A for extended transition function. The next one is epsilon closure of tilde cap of Q2 epsilon comma B. The answer is epsilon closure of Q2 epsilon is Q2, so you write it as Q2B. Epsilon tilde of Q2B is Q2, so epsilon closure of Q2, which gives the answer as Q2. So now the calculation is over. This step 2 is over. Then what is step 3? You should draw NFA diagram. So what are all the states available in epsilon NFA? 3 states are available. The same 3 states are also available in NFA. So you put that states. Okay. Then you should find out epsilon NFA value. So first you check what is a epsilon NFA final state. Here it is Q2. So how can you calculate final state NFA value? It's nothing but epsilon closure of Q2. What is epsilon closure of Q2? It's Q2. Now you check this Q2 value in this step 1. So here epsilon closure of Q0, in the answer there is no Q2 values there. But if you go for epsilon closure of Q1, Q2 is available. In epsilon closure of Q2, this Q2 is available. So these Q1 and Q2 states are considered as final states. So I encircle those 2 states with a double circle. Once again, I repeat the procedure. After calculation of extended transition function for all the function, you should draw the NFA states, in which we should find out the final states. So first you check the final state of epsilon NFA. The answer is Q2. How can you calculate NFA final state means which is equal to epsilon closure of that final state of epsilon NFA. So the answer is Q2. So you just check epsilon closure of Q2. So it contains only Q2 value. So you should check this Q2 in step 1 of the final resultant answers. So in which epsilon closure of Q1 and epsilon closure of Q2 both contains the answers of Q2. So we consider that Q1 and Q2 are final states. So I encircle those 2 states with a double circle. Is it clear? Then you draw the outflow. So before going to diagram, you just draw NFA transition table first. So how many input symbols? Only 2 input symbols. How many states are there? 3 states, Q0, Q1, Q2. In which final states are Q0 and Q1. You write the answers. So this is the tilde dash value. Okay. This will be retried from tilde dash value. So what is the answer of Q0A? It is Q1, Q2. So you write those 2 states here. Q0B? No. Q1A? No. Q1B? Q2 is there. Q2A? No. Q2B? Q2. Then from the table you draw the diagram. So from Q0 A, how many states outpath is there? From Q1 and Q2 with the symbol A. Then Q0 B, there is no state. Q1A, there is no state. From Q1 to Q2, the input symbol is B. Then from Q2A, no. Q2B, the same state. So this is the NFA diagram. This is the resultant answer. Are you clear about it? So now you see the same set of states are also available in NFA, but in the NFA there are 2 final states are there and there is no epsilon path in the resultant DFA. So this is the answer. Either you draw the diagram, otherwise you draw the transition table, but in the examination these two are compulsory. Okay, thank you.